So if you're a data scientist, you know the feeling, right? That frustration when all the tech stuff, the infrastructure, just gets in the way of the actual science. Well, today we're going to dive into a tool called Docker that can totally change the game. It's all about turning that chaos into a smooth, repeatable process that you can share with anyone. Let's get right into it.
Oh man, we have all been there. You spend weeks, maybe months, getting a model to work perfectly. It's beautiful. It runs like a dream on your laptop. And then you try to hand it off. And crickets. It just breaks. That one phrase, "but it works on my machine," has probably killed more projects than we'll ever know. It's infuriating.
So what's really going on here? Why does this keep happening? Well, deep down, it's because there's this built-in conflict in what a data scientist is asked to do. It's a real dilemma, pitting two totally different kinds of problems against each other.
In this slide, this really nails it. On one side, you've got the modeling problem. This is the fun stuff, right? The algorithms, the insights, the creative part of the job. This is where you, as a data scientist, really shine. But then there's the other side, the engineering problem. Managing libraries, fighting with servers, just wrestling with the environment. And as Joshua Cook points out, this is where things can really fall apart.
And this is where our hero finally enters the story. There's a technology out there designed specifically to help you crush that engineering problem, so you can get back to what you actually love doing. Yep, you guessed it, we're talking about Docker.
Okay, so what even is Docker? What's a container? Well, think of it like this. Imagine you could take your entire project, your code, all the libraries it needs, the configuration files, everything, and pack it into a neat little box, a self-contained bubble. Now you can ship that box anywhere, to a colleague's laptop, to a massive cloud server, and it just works. Exactly the same, every single time.
You know, the source material has this fantastic analogy that makes it all click. Think about it like you're writing code. First, you have the Docker file. That's your source code, your human-readable recipe. Then, you build it, and that creates an image. The image is like your compiled program, a static blueprint. And finally, you run the image, which creates a container. That's your actual running process. See? Source code, compiled binary, running process. It's a really powerful way to think about it.
Okay, so theory is one thing, but let's see what happens when the rubber meets the road, especially when you don't have this superpower. We're going to walk through a super common data science problem and watch exactly where it all goes wrong. So here's our setup, taken right from the book. You've got a data scientist, probably you, working in a Jupyter notebook. It's running in a pretty basic Docker container on a small cloud server, one of those tiny AWS instances with just 1 GB of RAM. It's a classic setup for trying out a new idea. All right, so we start generating some data, and keep an eye on the memory. With a small data set, we're using about 153 megs. No problem. We scale it up a bit, 10,000 rows. Okay, memory's creeping up. Now, let's make it wider. 10,000 rows by 2,000 columns. Whoa, now we're at almost 280 megs just for the data itself. You can probably see where this is going, can't you?
And there it is. We try to create a slightly bigger data set, and boom, memory error. The program crashes. The kernel dies. Your experiment is just over. Not because your code was wrong, but because you just flat out ran out of memory. You hit a physical limit.
And this quote from the book just says it all. And with that, you have hit the memory ceiling for your current system. See, it wasn't a bug. It was an infrastructure problem. This is the exact wall that data scientists slam into all the time.
So, that's the wall. How do we break through it? Well, this is where we start thinking bigger than just one container. This is where we use Docker to build an entire, powerful, interconnected stack. Think of it like building with digital Legos. The cool thing is, Docker isn't just for your Python script. It's for the whole shebang. You can have one Lego block that's a PostgreSQL database for your structured data. Snap on another one that's a Redis cache for super fast lookups. Maybe add another for your unstructured data in MongoDB. And this is the really key part. You connect these to what's called a Docker volume. Just think of a volume as a permanent hard drive that lives outside the container. So if your database container ever crashes or restarts, don't worry, your data is totally safe. Okay, so you have all these different Lego blocks. How on earth do you manage them all? Well, that's where this amazing tool called Docker Compose comes in. It's basically the instruction manual for your entire project. You write down all your services, your notebook, your database, your cache in one simple file. And then you just type one command, Docker Compose up, and the entire complex system just springs to life, all connected and working together. It feels like magic.
All right, so now we have the tools, we have the blocks, but the real secret sauce is how you put them all together into a professional workflow that takes you all the way from a messy idea to production-ready code.
And this workflow laid out in the book it's brilliant. Here's how it works. You start where you always start in a Jupyter notebook. You explore, you experiment, you make a mess. That's what it's for. But as soon as you find a piece of code that works, you clean it up into a proper function. You test that function right there in the notebook until you know it's solid. And then, and this is the absolute game changer, you move that battle-tested function out of the notebook and into a reusable Python module. Now it's clean, production-ready code that you can just import whenever you need it.
This quote from Joshua Cook totally reframed how I think about Jupyter. It says, Jupyter doesn't replace Vim, Jupyter replaces if_name_equals_main. It's not supposed to be your main code editor. It's your interactive playground, your command center. It's where you drive and test the clean production quality code that lives in your modules. What a powerful idea.
So what's the big payoff here? What do you get at the end of all this? You get a complete data science environment that's repeatable, scalable, and so easy to share. You can literally give your project to a coworker. They run a single command, and your entire stack, the notebook, the databases, everything, is running on their machine, identically. That nightmare phrase, "it works on my machine," just disappears, for good.
So, I want to leave you with this question to think about. Think back to that one project. You know the one that was an absolute nightmare to set up or to share with anyone else. Now, what if you could rebuild that whole thing inside your own personal portable data lab? What kind of amazing things could you build then?